Good day, guys. Today I will be solving for this problem as I promised last video tutorial. So I'm using this book. So page 46 of the book, problem 267. So the problem states that the howe roof truss shown in figure P-267 carries the given loads. The wind loads are perpendicular, so these are the wind loads, and perpendicular to the inclined members. Determine the magnitude of the resultant, its inclination with the horizontal, and where it intersects AB. So we will locate the resultant and the inclination that intersect this member AB. So we have already the answer, which is 10,760 pounds down to right at 68.2 degrees and 16 feet to the right of A. So let's begin. So first we would like to compute for the resultant. So the resultant is just equal to this summation of these forces, but we know that the resultant is summation of forces x squared plus summation of forces y squared. So we would like to sum up forces x and sum up forces y. So first I would like to sum up forces y. Summation of forces y is just equal to 3,000 negative minus 2,000 minus 1,000. Then the y component of these three forces. So first we would like to know the angle of these three forces. So if we will extend this and this, so if this is theta, this is also theta, and this will be theta. So and this is perpendicular, so this is 90 minus theta. So we would like to solve for the theta. So the theta is equal to tangent of opposite over 20. So it's 26.57 degrees. So this is our theta. So 90 minus theta is equal to 63.43. So this is this theta will I am going to use to find the to use the y component of these three forces. So minus 1120 sine of 63.43 minus 2240 sine 63.43. Then last is 1120 sine of 63.43. So our forces y is just equal to 3.43. So we have negative 10,006.86 pounds. So this is our the summation of forces y. So now summation of forces x. So x is just equal to 2000 plus 120 cosine of 63.43 plus 2240 cosine of 63.43 plus 1120 cosine of 63.43. So our summation of forces x is so we got 4,003.86 pounds. So this is the summation of forces x. So by looking at the sign of these two, we can say that our resultant is going down right. So this is our resultant, down right. It is down right, but we don't know the location of our resultant. So now we can solve for the resultant. So resultant is just square root of summation of forces x squared and the summation of forces y squared. So 4,003.86 squared. So we got 10,0778.13 pounds. So this is our resultant. This is our resultant. Then we would like now to sum up moment. So in my case, I would like to sum up moment in this point. So point A. So this is point A. So for the moment arm of these two forces, I would like to solve for this hypotenuse of this triangle. So the hypotenuse is 10. So it's 5 squared plus 10 squared. So this is 5 square root of 5, and also this is 5 square root of 5. So this is our distance from this force to the point A, and this point to the point A. So we can now find the moment in this point. So why we would like to know the moment in point A? So because we have this formula, so moment force times distance. So we already solved for the force, which is our resultant, but we don't know yet the moment. So we would like to find the moment. So summing up moment at point A. Summing up moment at A is equal to so obviously this force will become 0 because it is directly to the point where we will sum up moment. So 0. Then 2 to 40 positive times 5 square root of 5 plus 120 times, so this is 10 square root of 5. Then we have 2000, so plus 2000 times, this is 5 then plus 3000 times 10 plus 2000 times 20, then plus 1000 plus 30. So our moment is so we got 16,000 or 160,087.92 lb feet. So this is our moment. So we already have the two requirement for our distance. So what is this distance? The distance from our moment center. So now we all know that our our resultant is downright. So imagine if this is our A and B, because we are asked to locate the resultant that intersect these two in these 2 points. So we know that is downright. So maybe we just say that the resultant is here, not really. This is just as estimation. So this is the resultant of 10,778.13 pounds, but we don't know the distance yet. So we would like to find the angle here. So the theta 1 is just equal to summation of forces y. So 10.86 over summation of forces x. So our it is 68.19. So the angle, the theta 1 is 68.19. So now we can sum up moment, or we can now solve for the distance. So by the way, we will just use the x, or the y component of the resultant, because if this is the rx and this is the ry, so basically the rx will become 0, because the moment is here, right? And the line of force is passing to this point, or the distance is 0, because it is on the point of our moment center. So we will just use this the y component of the resultant, because by doing so we will be solving this. Then if you are asking why we can't use this resultant to solve the distance, because remember that the moment arm is the shortest distance from our moment center. So if we put this like this, so if we use the resultant as a whole without using the sign condition of the resultant, we will be solving, we put this as n. So if we use the resultant without the sign, we will be solving this distance. But if we use the y component of the resultant, we will be solving this. So ry is just equal to 10778.13 sine of our theta 1. So sine 68.19. So this is the force that we will put in our formula, which is this. So this is the F of this formula, or yes, so our distance is just equal to moment over force. So our moment is 16,087.92 over our force of 10,000.13 sine of 68.19. So our distance is 13 sine 68.19. It is 15.99, or you can say it's 16 feet. So again, if we have a positive moment, so if we have positive moment, then this 16 feet is to the right where we sum up moment. So this 16 feet is to the right of point A. So that is the condition if we have a positive moment. So if this moment is negative, then this 16 feet is to the left of A. So it is out of this truss. So basically the resultant is 16 feet to the right of A. So 15 may be here. So basically our resultant will fall here or intersect on this point. So this is the R of 10,778.13 lb. So this is our resultant for this truss. So it is downright 16 feet to the right of A. So if you notice earlier, the book only gives us so the book gives us 10,760 pounds of resultant, but in our solution we got 10,778 pounds. So although our our angle is correct, which is 68.219, and the book is 68.2, and also the book has 16 feet to the right of A. So we also got 16 feet to the right of A. So maybe I don't know if there is something that I did wrong or error in solving this resultant, or maybe there is just a typing error in the making this book. So let me know down below if I made a mistake. So that's how you solve for the resultant of this truss. So for our next tutorial, maybe so we are now in equilibrium because we already done here. So we are now in equilibrium for system. So maybe I will be solving this for you. So if you want to be updated in my next video tutorial, so please do subscribe and hit the button bell, so you will be notified in my next videos and tutorials. So that's it. So hope you learn something new in my tutorial. So this is my solution. So here it is. So if you notice some error and mistakes, so please don't hesitate to comment down below. And also if you have some questions and recommendation to solve, so don't also hesitate to suggest down and comment it down below. So thanks for watching, and hope you learned something. Thank you.